So just to make sure everybody's clear on the updated schedule, because we have a short class today, we're not able to do the review that I wanted to do. We'll do that tomorrow. And then your test that was scheduled for tomorrow will be on Thursday. Yeah. However, since you were going to be ready for it yesterday or tomorrow, then it doesn't matter, right? So our purpose for today then is to go over homework questions that you may have, and that was a good time.
Was there homework last night?
Let's see here. Yeah, essentially. So it turns out that I failed to post this, and you can just do it tonight and give it to me tomorrow. So there it is. But when I'm opening the court of homework questions, it's more general. If you have any from previous sections, that would be okay too. What's that?
191.
Paper?
Okay.
Yes.
I turned my homework in yesterday because I couldn't find you in your mailbox.
Great.
Did you get it?
I will.
Okay. Well, there was one problem I had issues on.
Okay. Do you remember which one?
Let me check.
While you're checking, Josh?
49.
Okay.
A square uniform raft, 18 meters by 18 meters, of mass 6,800 kilograms.
Okay, now let's pause for just a moment. How big is 18 meters by 18 meters?
I don't.
1,800 centimeters.
What I mean is yeah, but physically, how large is 18 meters?
No.
No, much bigger.
Much.
Yeah.
Much bigger.
A meter stick is 800.
Yeah, a meter stick is basically a yard, right? So we're talking about 18 meters would be 18 of these. About 5 of these goes across the classroom, so 3 classrooms.
Well, it says is used as a ferry, so it's
It is used as a ferry boat. Okay, good. Okay, so we got 18 meters, 18 meters. What's the mass of this guy?
6,800.
6,800 kilograms. Which is going to be roughly 6 tons. 6.5 tons. More, yeah, closer to 7 tons.
Are we going to talk about like one these books?
We could, but I don't think we're going to have to. Or what?
If 3 cars, each of mass 1,200 kilograms, occupies northeast, southeast, and southwest corners, determine the center of mass of the loaded ferry boat.
Northeast,
Northeast,
300 kilograms? No,
1,200.
1,200. So actually, this is poorly drawn because probably it would be southeast, 1,200, and
Southwest.
southwest. Oh, yeah, it is southwest. And now they want the center of mass. And do they specify locations for those cars? They just say in those corners?
Yeah.
By those corners. Okay.
Well, it doesn't compare what is 6,800 unit of like.
Great question. Okay.
Do you just treat it like it's an insect? Or
Yes, that's exactly it. When you have an object that is uniform, then its center of mass is going to be right at the geometrical center of that object. That's what we call the centroid of the object. Okay? So that means that I've really got 4 different objects, and I'm going to treat each one of the cars like it's in the exact corner here because I don't know where else to put it. And so as a simplifying assumption, I know that in real life, they would probably be, the center of mass would probably be, half a meter or so inside. But this is close enough. And I also figured that there will be a little bit of canceling effect right here. So it's a good approximation. So now it's just a matter of center of mass is equal to the sum of masses times positions, or the sum of moments divided by the total mass here. So I need to identify some positions, which means I need a reference frame. What's your reference frame going to be?
The book I saw in the answer used the centroid of the raft as the origin.
That works for me. So this is going to be 0, 0. And now from that we get coordinates for all the rest. Let's just go around the horn here. Any coordinates?
-9, -9.
Yep.
9, -9.
Yep.
And 9, 9.
Yep. And now it's a matter of just going through and plugging them in. So we get 0 for the first one, because for the raft, because it's at the origin, minus or plus 1200 times -9, -9, plus 1200 times 9, -9, 1200 times 9, 9, and all of that divided by the total mass, which is going to be 3600 plus 6800 is 10400. And now, what do you observe about these computations before you go through and start computing everything?
We're going to cancel out.
Yes. Observe that some will cancel out. That's the basic thing we look for. In particular, we can see that these two will cancel out, right? Because 1200 times 9, 1200 times -9, add to 0. Maybe, let's see here, these two would cancel out. And so what you end up with then is 1200 times 9, all the x's, other x's have canceled. And 1200 times -9 there, because all the other y's have canceled. And so that gives me, in the end, 1200 divided by 10400 is 1.04, comma, -1. If we go back to our original problem, that gives us a center of mass, which is a little bit to the east and a little bit to the south on a 45-degree line right here. And that makes sense, because most of the car mass is on the east side, and most of the car mass is on the south side. And interestingly, notice that although we have twice as much car mass on the south side as we do on the north side, still in all, because the raft itself is so massive, that dilutes the effect of the two cars compared to the one, which is why this center of mass is not that far down. If the raft were of 0 mass, which of course is impossible, and that is some really light, strong material, if the raft were of 0 mass, then we would have a much smaller denominator, which would give us a number much closer to 9. Or, it would be pulled down much further. Yes, sir.
So that's why we put the reverse coordinate.
Yes, yeah, that's right. So what happens is, with ferries, what could happen is that if it gets significantly imbalanced, if the center of mass gets way out over here, really sort of above where the buoyancy is happening, then the whole thing can begin to go. And once it begins to go, then it goes very quickly, because as it goes, it gets worse. No, because of the angle. Find it?
Number 32, I think. So billiard ball A has a mass of 0.400 kg, kilograms, moving with a speed of velocity A, 1.8 meters per second, strikes ball B initially at rest, mass 0.5 kilograms. As a result of the collision, ball A is deflected off at an angle of 30 degrees with a speed of 1.1 meters per second. So the first question is, taking the x-axis to be the original direction of motion of ball A, write down the equations expressing the conservation of momentum for the components in the x and y directions.
Okay. First of all, we're doing a before and after diagram as usual. This makes sense here, this makes sense here, but what about the 0.5? Which way is it going to go?
Probably down on the angle.
Right, I mean, I'll take the motion of your hand. We'd say down and to the right.
Yes.
Yeah, okay. So it's going to go there. And your intuition about that is based on your intuitive understanding of conservation of momentum. The momentum of the system before is all this way, in the x direction. And therefore, the momentum of the system after must all be this way, in the x direction, which means these guys have to cancel out. So that's your intuition. All right? Now, what'd you do with it?
Okay, so I did the P initial equals P final.
A very good place to start. Okay?
So then I took its mass times velocity, like the MA times VA plus MB.
Okay, and what'd you use for the
1.80, comma 0.
good, right. So you avoided the first trap. Some people try to use speed here, and that will not help you.
And then plus 0.50, which is, yeah, 0.
Notice, by the way, this symbol 0 right here actually stands for the 0 vector. It's a vector with component 0, 0. When you add it to any other vector, you get the same thing.
Okay, then it equals 0.4 times, so it'd be like sine of 30 equals opposite of the hypotenuse. So that would be x over 1.1.
Okay, I see why there's a problem. If you look at these components actually,
Yeah.
the x component is the cosine.
Okay. Yeah.
And the reason for that is that our angle is actually measured from due east. So as soon as you see that, you fall into the default. X is cosine, y is sine.
Right.
So that was probably where the thing was going south for you. 30 cosine is 0.953. And then this would be 0.55. I can do the sine easier than the cosine because the sine of 30 degrees is 1/2. And then, how about for the other one?
Then it's 0.5 times, could you do negative for, or, I guess you don't know, so you should put VP.
Yeah. Just because V is going down does not mean that I'm going to represent it as a negative vector. Vectors don't actually have signs to them. They're components to it. When I say opposite of V, that means a vector in the opposite direction from the original one. So if you were to put a minus sign right here, then that would indicate that we're actually like subtracting and somehow making it go this way. What's that?
It'd be going down the
It should be going down and to the right.
Yeah.
Okay.
And then the rest is easy, so you just.
Yeah, and then the rest is easy because you multiply through and subtract and divide. And if you've not already done so, guys, go ahead and solve for VB.
I think we did this problem in class, I just had a problem solving it, so.
And That's the, I'll see you tomorrow.
Take that.